Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic, the iterative or repetitive statements in C. What are repetitive statements and why are they needed? Repetitive statements are used when you want to execute a block of code repeatedly. Say, we want to repeat some operation n times in the code, or you want to repeat some operation until a condition is reached. We can make use of a repetitive statement to achieve this. Iteration is the number of times a loop runs. We have three types of repetitive statements in C. We have a for loop, a while loop, and a do while loop. In every type of repetitive statement, there will be three kinds of expressions. Expression 1 for initialization, expression 2 to check the terminating condition, and expression 3 to approach the terminating condition. Let's consider a simple example for loop to illustrate. Here, for I assigned 1, I less than or equal to 10, I plus plus represents one for loop. In this case, the body of the for loop will execute 10 times. I is initialized with 1. And how we go from 1 to 10? By incrementing I using the statement I plus plus. In every iteration, we check if I is less than or equal to 10. Until that condition is true, we execute the loop and we terminate the loop once the condition becomes false. Here the expression 1 is an initialization expression, I equal to 1. Expression 2 is a conditional check to ensure iteration does not exceed 10, I less than or equal to 10. This expression terminates the loop if the value reaches 10. And to reach the termination, we are using the operation in expression 3. So expression 3 is I plus plus to approach the termination. Now let's consider a simple use case. Say we want to accept 10 inputs from a keyboard. So instead of writing the scanf statement 10 times line by line, the simple way to do is run this loop and put the scanf inside the body of the loop and receive 10 inputs. Similarly, we can use printf inside the body of the loop to print 10 numbers. And we can use the loop to process 10 numbers. We can execute the loop 10 times and process one number in each iteration. So, similar way, while loop and do while loop functions. While loop has the following syntax. Before while loop, we have to have an initialization, that is expression 1, I assigned 1. This is an expression 1. Expression 2 is a terminating condition. I less than or equal to 10. If I becomes greater than 10, the loop terminates. And expression 3 is to approach the termination. Each time we increment the value of I using I assigned I plus 1 in order to reach from 1 to 10. Do while loop. Expression 1 is initialization. Then we have expression 2 to approach termination. And finally expression 3 is a terminating condition. The difference between while and do while is that at the start, if I had a value 11, for instance in this case, what would have happened? While would have executed not even once, because I is not less than or equal to 10. This condition becomes false. That control never reaches the body of the while loop. But in case of do while, even if I were to have a value 100, the do while statement executes the body once and then it will check the condition. So based on your use case, whether you want to enter the body of the loop after checking the condition, or you want to execute the body once before checking the condition, you can make use of while loop or do while. So all these three constructs, the for, the while, and the do while, do the same task of executing the body n number of times. They ensure the body inside the loop executes n number of times, either for receiving input, displaying output, or for processing the data. Now, let's consider a form of while loop or for loop used in most of the applications. This is one more way of writing a while loop or a for loop. Instead of an expression, we are having a value true always. Such a loop is called as an infinite loop. The body of this loop executes indefinitely. Inside the body of the loop, we can handle operations or events such as IO, which may generate some terminating signal. And based on that terminating signal, the loop may terminate. Otherwise, it executes forever. Let's consider one simple example program to understand this. Let's check the example where we had to use switch to print the day of a week given the number. And extend this example by using a while loop or a for loop. X is the expression. How did we get X? By using a scanf state. We are accepting X. On the basis of what value the variable X has, a particular case statement will execute and it will print the day of the week. And if there is an error, it will print the error and it will break. This while loop executes indefinitely. If the value of X is between 1 to 7, the loop keeps on executing. But if we execute this code with a value of 0 or a value greater than 7, then what happens? The loop will break. For a value other than 1 to 7, switch will print an error and then the control is transferred to an input validation outside switch. Here we are checking if value of X is between 1 to 7. If X is less than 1 or if X is greater than 7, the loop terminates with an error. You can observe here, the first break is to break a case statement inside the switch, whereas the second break is to break the loop itself. What is the logic here to approach the termination? Actually, it is the out of range value from the input event using the scanf, which acts as a terminating signal. If you input a value which is not in the range of 1 to 7, the loop terminates. Example, if you give a value out of range, say for example 0, 8 or 9, that becomes a terminating condition and the loop terminates. Now, in this program, we can replace the while loop with a for loop and we will get the same results. So this is about how to implement an infinite loop and then handle an event inside the loop. But why do we actually need an infinite loop? Infinite loops enable a program to run continuously, such as operating systems, servers, and real-time systems, which must run indefinitely until explicitly stopped by an event. Applications can wait and respond to events like user inputs or network requests and ensure the program handles these events when they occur. So this is about loops. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.